Have you ever wondered how the smallest changes in our genes can lead to significant differences in our bodies and health? In the fascinating world of genetics, minute shifts in our genetic material, specifically in our chromosomes, can result in a myriad of genetic conditions. This is the intrigue of chromosome abnormalities. Chromosome abnormalities, as the name suggests, are changes in the number or structure of chromosomes. Imagine chromosomes as the blueprint of a building. Even a small alteration, like moving a wall or adding an extra room, could drastically change the final structure. Similarly, these chromosomal changes can introduce a variety of genetic disorders, from Down syndrome to Turner syndrome. These abnormalities can be broadly categorized into two types: structural abnormalities, where there's a rearrangement or deletion in the chromosome parts, and abnormalities of chromosomal number, where the total count of chromosomes deviates from the norm. As we delve deeper, we'll uncover the various types of chromosome abnormalities and their impacts. Firstly, let's explore the abnormalities in chromosomal number. We have two intriguing types to discuss: aneuploidy and polyploidy. Aneuploidy is when the chromosome number isn't a multiple of 23. This means there's an extra or missing chromosome. Polyploidy, on the other hand, is when the chromosome number is 3 or 4 times the haploid number of 23. That's a significant increase. So, how do these abnormalities occur? Well, they generally arise from one of two ways. The first is meiotic non-disjunction, which is a fancy way of saying the failure of chromosome pairs to separate during cell division. The second way is through anaphase lag, which is the loss of a chromosome during cell division. These abnormalities in chromosomal numbers can lead to a variety of genetic disorders, which we'll delve into shortly. Stay tuned to learn more about how these chromosomal disruptions can impact our genes and our lives. Next, we venture into the realm of structural abnormalities. First on our list is deletion. This is where a part of a chromosome is lost or deleted. Imagine a sentence with a word missing. It might still make sense, but the meaning could be altered significantly. Next up is translocation, a sort of exchange program at the chromosomal level. Here, parts of non-homologous chromosomes, or chromosomes that are not pairs, swap places. It's like swapping the chapters of two different books. Intriguing, isn't it? Then we have balanced translocation. Despite what the name might suggest, things are not always balanced in the conventional sense. Here, no genetic material is lost in the exchange. This usually results in a person who carries this being clinically asymptomatic, meaning they show no signs of the abnormality. Robertsonian translocation is a bit more complex. This occurs when the long arms of two acrocentric chromosomes join together, leaving the short arms behind. It's like two people joining hands and leaving their legs behind. A curious concept, isn't it? Lastly, we have inversion. This is when a portion of the chromosome separates and then reunites, but in the opposite orientation. It's akin to reading a sentence backward in a paragraph. Structural abnormalities, though small, can lead to significant changes in our genetic makeup. Now that we understand the types of chromosome abnormalities, what does this mean for us? Well, the implications of these abnormalities are as diverse as the types of abnormalities themselves. They can manifest in ways that range from minor physical or mental changes to severe health conditions that can significantly impact an individual's quality of life. Let's take aneuploidy, for example. This condition, characterized by a chromosome number that isn't a multiple of 23, can lead to disorders such as Down syndrome, where an individual has an extra copy of chromosome 21. This results in a range of physical features and intellectual disabilities. Similarly, polyploidy, where the chromosome number is 3 or 4 times the haploid number of 23, can lead to spontaneous miscarriages or stillbirths in humans due to the incompatibility with normal development. Translocations and deletions, on the other hand, can disrupt specific genes, leading to various genetic disorders. For instance, a deletion in the short arm of chromosome 5 results in Cri-du-Chat syndrome, characterized by a high-pitched cry, physical abnormalities, and intellectual disability. While these impacts may sound overwhelming, it's important to remember that these conditions are relatively rare. Most importantly, understanding these chromosome abnormalities provides invaluable insights into our genetic makeup and can guide research and medical interventions to help those affected. Understanding these chromosome abnormalities helps us to better grasp the complexity of our genetic makeup and its impact on our health.